In this ACT review video, we're going to talk about the distance formula and the midpoint formula. So here I have two ordered pairs and a graph, and we've got the points 2, 3, and -1, -1. So let's just graph those 2 points, 2, 3, right here, and -1, -1. And if we connect those dots, we get this nice little line segment. And because it's not a horizontal line and it's not a vertical line, we can't just count the squares to figure out how long the line is. So what we're going to talk about today is the formula that'll give us the length of this line segment, or what we say the distance between those 2 points. So we're going to figure out how long that segment is, and we're also going to figure out the exact middle point. We can probably estimate that that middle point is somewhere in there, but we've got a nice formula that'll give us the exact answer. So let's start with the distance formula. Here's our directions. Find the distance between each pair of points, and we've got the points 2, -4, and -1, 0. The distance formula is represented by a lowercase d, and it's a big square root, and it's x2 minus x1 squared plus y2 minus y1 squared. Okay, there's two things I want to point out before we start plugging things in, and that's, first of all, we've got subscripts here, the 2, the 1, and this 2 and this 1. And like we talked about in the slope video, those have no numerical meaning. Mathematically speaking, they're just names. That just means we have two x's. That means we have two 1s. It's just names. But up here, we do have a mathematical meaning of an exponent that's squaring something. So that is going to be some type of mathematical operation. Now, with any formula, I always just recommend to go ahead and label your points. It just makes things easier when it comes to this plug-in stage. So I would call this x1, y1, and this x2, y2. Then I can go ahead and just plug in, and I don't make any mistakes this way. And this gives me -1 minus 2 squared plus 0 minus -4 squared. And you always want to consider your order of operations. They rule everything. It doesn't matter what math you're doing. And we're going to bring down our radical sign inside the ordered parentheses first. Working inside the parentheses first. Remember, parentheses, then the exponents, then multiplication, division, then addition and subtraction. So in the parentheses, -1 minus 2 gives me -3 squared plus 0 minus -4. That minus a negative makes that a plus and leaves me with 4 squared. All right, now we're ready to do our exponents. Anytime you square a number, it's always positive. So -3 squared is +9 plus 4 squared is 16. Working our way underneath the radical, 9 plus 16 gives us the square root of 25, and the square root of 25 is just 5. So the distance between those 2 points would be 5 units. Okay, and this one happened to work out to be a nice perfect square. That may not always be the case. Okay, if you have a radical, you want to look at your answer choices on the ACT. They've most likely simplified the radical. By that, I mean not a decimal answer. All right, let's do one more distance formula, and then we'll move to the midpoint. Here we've got 8, -1, and 2, 3. So I would label this x1, y1, and x2, y2. And let's write our formula down. And remember, those are just labels. That's all we've done is label those. Those 2's and 1's don't have any mathematical meaning. And our formula is x2 minus x1 squared plus y2 minus y1 squared. I'm going to have to make my radical a little bit longer. And now we're ready to plug in. And since I have them labeled, I don't have to worry about getting things mixed up. I just have to put things in the correct spot. So big square root, that's going to be 2 minus 8 squared plus 3 minus negative 1 squared. And again, my radical's not big enough, so I made it longer. Order of operations, we have to work inside the radical and inside the parentheses. Inside the parentheses, we've got 2 minus 8, which is negative 6 squared, plus minus a negative makes that a positive. 3 plus 1 is 4 squared. And now we're ready to do our exponents. Anytime you square a number, it's always positive. Negative 6 squared is 36, plus 4 squared is 16. We're going to add those two together. 36 plus 16 gives me the square root of 52. All right, now 52 is not a perfect square, but it's an awfully big number. And so we need to find two factors of 52 so that one of those is a perfect square factor. And what we can do is we can rewrite the square root of 52 as the square root of 4 times the square root of 13. 4 times 13 is 52. And that works out because the square root of 4 is 2. So we're going to write our final answer as the distance is equal to 2 square roots of 13. So this is a simplified radical, not a decimal answer. Now, the midpoint formula is a little less work in my opinion. Here we're going to find the midpoint of the segment with the given endpoints. Okay, so we use a capital M to represent midpoint. Remember, we used the lowercase m when we talked about slope of a line, so there's a difference. And all you have to do here is add your x's and divide by 2, add your y's. So we write it formally as x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And all that says is add your x's together, divide by 2, add your y's together, divide by 2. You can go ahead and label your points just like I've done on all the other formulas, x1, y1, x2, y2, capital M, big parenthesis, 4 plus 2 divided by 2, comma, 5 plus 3 divided by 2. And we want to clean that up. 4 plus 2 gives me 6 divided by 2. 5 plus 3 gives me 8 divided by 2. We can simplify that a little bit more. Capital M equals 6 divided by 2 is 3. 8 divided by 2 is 4. So the midpoint between those 2 points is 3, 4. And remember, midpoint is just another point. It's the point in the middle, so we write it as an ordered pair. All right, let's do one more example. Let's find the midpoint between the ordered pairs 7, negative 5, and 0, negative 2. So we're going to label this x1, y1, x2, y2. We're going to write our formula down. Capital M for midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Then we just plug in. Capital M is equal to 7 plus 0 divided by 2, comma, negative 5 plus negative 2 divided by 2. And cleaning this up a little bit, 7 plus 0 is 7 over 2, comma, negative 7 over 2. And I can't simplify those anymore, so I'm just going to leave them as improper fractions. So that'll be my final answer. So that covers the distance formula and your midpoint formula.